Here. In this video, we are going to go over the right hand rule. All right, let's begin. So let's first discuss what is the right hand rule. It's not just for magnetism. It's actually a tool used for cross product. And specifically, the idea behind cross product, let's just write down the formula, is if you have vector C, if you multiply vectors A times vector B, you get vector C, right? And this cross product idea here, sometimes on the formula sheet, you might see it written like this, AB sine theta, okay? If you remember back from mechanics, we discussed cross product when it came terms with torque. Let's use torque as the example at first. So this is my axis of rotation, and if this is my like bar or like a door that I'm trying to push, if this here is my radius r, right? So that'll be my vector a, and if I exert a force here, okay, so this will be my vector b, right? So this is my a vector and this is my b vector. What we end up with is a rotation, and that rotation we call torque, right? And so the important thing from this example here is that the cross product requires your vectors to be as perpendicular together as possible. So though 90 degrees gives you maximum cross product, and 0 degrees or parallel gives you no cross product. And so the more perpendicular your two vectors are, the more of a resultant you get. The more parallel things are, the less of a resultant you get. Okay. Now, the reason why we call it the right hand rule, and there's different variations of this, is that your right hand will tell you the direction of your resultant. Okay, so I'm going to try my best here to sketch and write down what each finger would represent, right? So if our formula is C is equal to A cross B, and just from here on out, just know that I'll have these vector symbols above each one of those because it's each a vector, okay? Um, your middle finger, okay, so this is your middle finger, and your pointer finger are the two things that you're multiplying by, and the product will be your thumb. Okay, so essentially what you're doing is you're using your right hand to see. Okay, so if my pointer finger is pointing in this direction, my middle finger is pointing in this direction. If I were to multiply all of these together, what direction is my resultant, which will be your thumb? Okay. Um, And so the other important thing is that for the cross product, when you're using the right hand rule, all finger digits, okay, fingers and digits must be at a right angle. All right. The other important thing is we will always use our right hand. Sometimes you might use your left hand for different kinds of problems, but I almost always try to say, hey, it's called the right hand rule for a reason. Let's just stick with our right hand for the right hand rule. Okay, and I'll go over the different scenarios where you could use your left hand, but you can always do every single problem using your right hand. All right, so I'm going to show you a couple of specifics here, and as you're taking down your notes, I would love it if you actually practice with me so that you're used to using your right hand. Okay. Now, in terms of our notes, let's go over a formula. So this is called the Biot-Savart formula. Okay. So what this tells us is, so let's write down the formula first. We have dB, or a small chunk of a magnetic field, can be determined by the magnetic permeability. Okay, so that's the mu naught I dl cross product r hat, all divided by r squared. All right, so this is a formula here. What I'm going to do is I'm going to highlight the different parts that will tell us the direction of our fingers. Okay, so let's start off with this dB. This dB will be your thumb. Okay, and so what this tells us is the direction of the B field. Okay, the thumb will tell you the direction of the B field. That's our dB. All right, next we have, I'm going to do this in a different color. Ooh, let's do this right here. We have IDL. Okay, so for IDL, this is going to be our pointer. Now, if we think about it, I is just a charge that is moving. Okay, so it's a charge that is moving. So we say that's V. So the way that I think about it is, if you have like your finger out like this and go pew 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 pew, right? You can just imagine just charges like shooting out your finger, right? It's like pew, it's just shooting out. And the last one, of course, is here. This will be your middle finger. And this is the direction of the points that you're trying to observe. All right, so let's get this off here on the side, and at this point, we're going to do an example together. All right, so let's say we have a positive charge, okay, and the positive charge is going to be moving to the right. Okay, so this is our IDL. I'm going to use my color coordination system here. All right, and what we want to do is we want to see at this point here, so this is going to be my R hat, right? At that dot, what is the direction of my B field? So here, this is my, here I'm going to do a vector arrow here. Okay, so what is my B field? Okay, so you're going to get your right hand, and sometimes with these problems, like your arms are going to be twisting around in a very funky manner. Okay, as long as you just you have your fingers the correct direction. Okay, your hand doesn't have to be stationary, or your body doesn't have to be stationary. Definitely move your body around so that you're not twisting your body in awkward situations. All right, so if I'm trying to find the B field at that dot, I'm going to have my pointer finger. I'm going to point my pointer finger to the right. So I'm pointing my finger in the rightward direction. My middle finger is going to be pointing upwards, right? And you can already see my arms twisting. If you're doing it correctly, your arm should be twisting. So if that doesn't feel too comfortable, right, I'm just moving my body up and out. And I got to make sure my fingers are at a right degree angle. So if my pointer finger is pointing to the right, my middle finger is pointing up, I am now looking at the direction of my thumb. Okay, so my thumb is pointing away from the screen or away from the paper or towards me, my observer. So kind of like this, right? So I can see the thumb pointing directly at my face. So I would write that the B field is O. Now, in this notation here, okay, now we're in like a 3D notation where we know up, down, left, right, up, down, left, right. Okay, but what if we had a situation like this where your thumb wasn't pointing to the left or to the right or up or down? We use X's and O's. So O is what we call out of the page, or in this case, will be out of the screen or out of the paper, right? And then if it's into the page, right? So instead of like this, it was pointing like towards the screen like this, we would write it as X. Okay, so we'll see a lot of problems with X's or O's, but for this specific problem, we can see that the B field is directed out of the page. Now, if you want to see an example where the B field is directed towards into the page, all we have to do, right, because the way that the right-hand rule works is we just have this positive charge moving to the left, right? And we are still looking at this R point right here. So I'm going to try it myself. My pointer finger is pointing to the left. My middle finger is pointing up. And now I can see my thumb is pointing away from me or into the screen or into the paper. So for this one, my B field is at a X. All right, now I don't know about you, but my forearms and my wrist, from all that twisting, is a little bit complicated. Let's just do one more example. All right. Oh, left hand rule. Okay, so the right hand rule, this is important to know. The right hand rule, oops, is for positive charges. Okay, or anytime you're denoting a positive charge that is moving or a positive charge carrier that is moving. So let's take these two same examples, but instead of a positive charge that is moving, we'll say it's a negative charge that's moving. So it's a negative charge that's moving to the right, and we're looking at this point right here. So that's my R hat. Okay, all you have to do, because we know the answer should be O, okay, all you have to do, you can still use a right-hand rule, is just swap that signage. So instead of having B coming out of the page, the answer would actually be into the page because that's a swap. Or you can just use your left-hand rule, or you can use your left hand for negative charges, and if you do so, your thumb will point into the page. So you'll get this if you use your left hand. All right. Now, me personally, I do not recommend that you switch back and forth between your right hand and your left hand. Okay. I think it's better if you just make a mental note. All right, I'm looking at a negative moving charge. I'm still going to use my right hand rule, but at the very last minute, I'm going to just swap the signs. But that's my personal preference. Okay. So we have the Biot-Savart formula here. Okay, make sure you have that one down. And there's another rule for this. Okay, it's called the curl method. Okay. I personally like using this method here, but sometimes you'll be asked a curl method. And so this idea here is what you're doing is essentially you're creating a shape as if you're holding like a pole, or if you're holding like a broomstick, or you're just holding like a stick in your hand and your thumb is aligned with the pole. Okay, so it's going to look something like this. All right. Now, the way that the curl method works, right? I'm going to try to do a 2D version of this. Is your thumb points in the direction of the moving charge. All right. So let's say we had a wire, and that wire has a current. Here's my wire, right? So I'm looking, so not a flat wire like this, but we turn the wire. So instead of looking at it flat, we're looking directly at the wire. Okay, and the wire has a current coming towards your face. And so here I'm going to say that I is 0, right? So the current is coming towards your face. Okay, so this is the setup. In order to do this, right, your thumb represents the wire with the thumb pointing in the direction of the current. So at this moment, right, if you have your right hand, you're going to put your right hand and you're going to create that shape. You're going to have the thumb pointing towards your face, okay? And you're going to curl your fingers. So what the fingers curl shows you is the direction of the B field in a 360 instance. So if I'm looking at my fingers, okay, at the top, I can see my fingers are pointing to the left. So at the top, right, so if this is my thumb, right, so if this is my thumb, at the top of my hand, I see my fingers are pointing to the left. So what that means is that at the 12 o'clock position, okay, surrounding this wire, there's a B field that is going to the left. And the idea of the curl rule is you can continually curl your fingers so that it makes a 360 image. So here, if I continue that curl, the B field will be going down. And here, the B field will be going to the right. And here, the B field will be going up. And so we can actually continue this in a 360 manner, right? So it kind of looks like this. So we can see that all surrounding this wire, we have a curl, okay, of a B field surrounding it. So we can still use this not in a weird, like having the current coming out of the page or into the page, but also for a flat wire. So let's say this is our wire and our current is going to the right. All right. So this is one of those weird situations where I'm taking the example that I did before, where the wire is coming into and towards your eyeball. I'm just swapping it or like swapping the orientation so that I'm looking at it sideways like this. So if I am doing that, right, and a lot of times I like to suggest to students, right, whatever writing utensils you're using, right, pretend that that's your wire. So if this is my wire, I'm going to have my thumb point to the right, and I'm going to curl my fingers around my writing utensil. So I always like to start off at the top of the wire. So at the top of the wire, I can see that my fingers is pointing towards my face. Right? So if this is the wire, this is the direction of the current. Above the wire, the fingers are pointing towards my face. So here, at this point R, right there, the wire or the B field is coming towards my face. Okay, and it's going to 360 swirl around so that below the wire, right? So if I continue my fingers below the wire, the B field, right? Because this 360 makes a circle. Right? I'm going to try my best artistic interpretation. So the B field is going to go around, around, around. So at that point right there, the B field will no longer be going out of the page, but rather into the page, like so.